Welcome to my channel. Today we'll be talking about Docker. What is Docker, you might wonder? Docker is a open source platform for which provides the software for helping us package application in containerization of application basically, and it does this via something called a Docker daemon, which runs the Docker engine runs the Docker daemon, and then it receives requests from something called a Docker client. All of these work together, and there are some. Docker is a very popular software in most software development shops these days, and there are a lot of reasons for that. When it comes to deployment, right, it's mostly done via some kind of virtual box in a way. Some of you might be familiar with Vagrant, for which essentially is a virtualization of like an entire operating system pretty much, so that you can sort of sandbox your application by isolating it out that way. So all of this worked fine back then, but of course this came with some overheads, and as you can imagine, running just because you wanted to run not to trivialize any application, but like let's say you want to run a basic blog site now, and then you want to self-manage hosting it, of course, and then you had to like literally deploy a full operating system. This as you can imagine would lead to a lot of wastefulness of resources, right? And Docker comes with its own containerization technology. Of course, containerization is nothing new. It's of course has been around for quite a while now. But what Docker has done innovatively is to have this concept of, we have the Docker engine in itself. We have the Docker daemon, which runs, which is how we connect to the Docker engine, and then we have the Docker client. This is basically the architecture of how Docker works. And what happens is the Docker client, right, which is a CLI, and we'll see all of this in action in a minute, would issue a command, if you will, think of it as a request, but essentially it's a command, a Docker command to the Docker daemon, which of course knows how to talk to the Docker engine in itself. By doing so, it would help us, that is the architecture on a very base level. And why do we need to do all of this? I don't know if you've been in this situation where you deploy, you've done a feature, and then you are trying to send it to your peer to review, and of course after review wants to run this code and see things in action and be sure everything is where they need to be, right? And you find yourself in a situation where, what's going on? I thought you said you fixed this stuff, and then no, this thing is not running. It's running on my machine. It's not running on yours. Blah blah blah. As you can imagine, it can be very, very frustrating. Docker to the rescue, my people. What Docker simply does for you helps with in that regards, because it's a containerized it helps with containerization, and then packages up all this application, your software, as a simple image, right? This image, if you run that image on your machine and I run it on my machine, I would get the same thing that you would get. So you can imagine that in your CI/CD, in your deployment, in your staging environment, or whatever environment you are deploying to, one thing is guaranteed: you would have the same behavior in each stage, because Docker has helped by the containerization by providing you an image which is easily replicable across environment. And another thing about Docker is, like I mentioned, these images you can build your own, which I would also show you in a minute. And there are also a lot of already existing images up in the Docker registry. Docker has its own registry up.docker.com. I would also show you that in a minute. But then there are also other place where other providers that are running registry, and in fact you can even host your own registry if you want to, right? So without further ado, let's get right into it. Okay, so here is Docker's website. Not to worry, I would put the link to Docker on the in the description below, and you'll be able to see this website. And should you be following along, you can simply go to docker.com, right? And the thing I need you to do, which is a prerequisite for if you're following along right now, or you want to basically replicate what I'm doing, you'd have to download this Docker desktop. So depending on the operating system where you are running, you would need to download the appropriate one, as the case may be. For me, I'm on a Mac and I already have it installed. If I can get my Docker running, I already have it installed, and yeah, and I'm just putting it up basically. So let's learn some few Docker commands, and to get our muscle memory around some few Docker commands, and we play around with it and see how things are working. So without further ado, let's get started. So if you are done the previous step of downloading Docker from docker.com, that should give you the Docker desktop. If you're on a Mac, I believe the same for Windows and also for Linux, but yeah, you'd have something called a Docker desktop, and then it comes packaged, so you get everything I've mentioned earlier: the Docker daemon, the Docker client in itself as well, and of course the Docker engine. So we can verify that Docker is installed and running by typing just Docker, and you should get something like this, spitting out logs of everything that Docker can do. And you can also do Docker version, and you see the version in which I'm running. As you can see the Docker clients, right? And then you can see the Docker, in this case Docker desktop, right, the server. And you can see the engine version that I mentioned earlier. Yeah, so this tells us that Docker is up and running, which is good, which means you can get working, right? So cool, let's get started. So the first command I'd like to show you is something called Docker images, right? If you do Docker images, that's basically to tell Docker that, oh, what are the images I've got, list them out, and you can do something like Docker image ls. Is the same thing as saying Docker images. Another thing I want to show you, another command is called Docker ps, which shows you the running containers that are actively running. We have none running. We don't have any image running. We sure don't have any containers running. Images are the main, and then containers are spawned off an image. So you can think of image as a template for containers, right? So you need to have an image before you can have a running container. Get it? Cool. So how about, this is not exactly very useful for us right now, so how about we get some images? So remember earlier I mentioned we have something called the registry, and we can visit that at up.docker.com, which is a registry for looking for images that are already, that have already been pushed up the registry. And would also be creating our own custom image here today. So not to worry, we'll be getting there in a minute. But for now, let's just play around some few Docker commands and how just to get a good feel of how Docker really works right. So we'll start out running the BusyBox image. So All right, so one thing we need to do, another command that we'll be doing now is called docker pull. And if you look at the documentation here, right, you see it says docker pull busybox. So this is the Docker client that we've been using, and then the command, which is pull, and then the name of the image we want, which is busybox. So we'll do the same thing by saying docker pull busybox, and it's doing just that, pulling that image. Oh, that was quick. So if we issued the command we did earlier, docker image ls, now we have an image called busybox. That's the name of the image repository, and it has a tag called latest. You can think of tags as the version for that particular image in question. We have the image ID, and then we have stuff like when it was created, the size of the image. This is all good, but if we still run docker ps, nothing is running, right? Because we only pull down the image, but we've done nothing with it just yet. So how can we run an image, you'd ask? So we can do that by saying docker run the name of the image, which in this case is busybox. And if we run docker ps, looks like nothing was happening. What's going on? Well, an image essentially is a set of steps that you put in something called a Docker file. We'll see that in a bit. And it will Docker would go through those steps, and then run any command you expect it to run. Busybox is a very tiny image that specifically is just to like mimic your Linux box in a way. What happens is that there is really nothing to execute, really. So it closes off about immediately. So one thing we can do is to run it. If we check the documentation again, this is another thing I would encourage you to do if you have any issue with any container or image or whatsoever, and basically pretty much about everything about development. Always check the documentation. Something we can do is run, like the documentation suggested, is say we do docker run -it. That is yet another flag I want to show you. So we can do docker run -it, it being interactive, right? Which means we can literally interact with the container processing itself. So we specify the image again, like usual, busybox, and now this has dropped us inside the running container, and we can verify that by saying docker ps, and we see that we have something called busybox. The command is sh, and then it was created 10 seconds ago, and status and everything in between, like so. So what can we do with this? Pretty much your basic Linux commands. You run pwd, or what else can we do? We can do pings, we can do sdp.com, and we are getting something. And what else can we do? What else? We can run make directory, YouTube, and if we do ls, we have YouTube, and we can pretty much any commands of any Linux command you want to run, and you can do just that, right? So this is fun, but not exactly very useful, right? But before we go on, I'd like to show you one other flag. The flag is earlier when we ran the process and check the docker ps, we in fact, let's just do it again. If I split my terminal like this and we do docker ps, and we can see that everything from here was, of course, container id was generated. We know the image name. This is how the image is being run, which is sh. We understand all of this, but look at this name. how did this, what is this? We don't know. But so one cool thing that Docker does is when you try to run a container, right, and you don't specify a name, it automatically generates a non-conflicting name. By non-conflicting, that means like should there be other containers running, if it's auto-generating the name, there will only be, it will generate the name that no other container is running. Reason being that you cannot have two containers of the same name running at the same time, right? So how about we specify what we want to call it, right? Which I think can be very useful. So I'll show you the flag for that. Just like we add -it for interactive. Another thing we can specify is --name, right? Which is the name of the name we want to give the container that we're about to run, right? So, and for this, let's just call it YouTube, YouTube BusyBox. Just say YouTube underscore Docker, right? So, and if we do this now, if everything is going well, we should see YouTube Docker, just like that. So that will come in very handy. And in another example that I will show you in a minute, we would also see that in action. So another thing I would like to show you, another command I'd like to show you is called stop. So we have a container running. So what if we want to stop it and we want to trigger it to stop by ourselves? So there is a command called stop. So we have docker stop, and then we specify the container ID and or the container name. So Docker would terminate that process, the container that is running. So if we do this, Docker stop that, if everything goes well, I believe it should. Yes, and yeah, that took a minute, but yeah, it did stop the container. If you catch that for a sec, you'll notice that it broke out of the process here, which we were running, which would have been an interactive mode, right? Cool. So far we've gone through few commands. We've gone through Docker, the architecture of Docker high level, and now we've gone through commands like images to get a list of images that are there, to get running containers, to also stop a container. We've learned flags, like if we are running a container and we want to be interactive, we've seen that in action. And should we want to name the container, we've seen that as well in action. All these are good, but how about we do something a little bit more useful? BusyBox, it is useful, don't get me wrong, but at least something we can play around with and see some of these cool things in action. So I would like to introduce us to Nginx. I don't know if you're familiar with Nginx. Nginx is a web server, a very popular web server at that, and it runs by default on port 80. What Nginx does basically is for reverse proxy, and I believe some people use it for way more things than that. But basically, it's a web server. Okay, so we are going to try to run this web server, and because it's a web server, you can expect that it would have a default web page, right? And we'll see all of this in action in a second. But before we go there, I'd like to mention, if you remember earlier, when we did do Docker pull, because we didn't have BusyBox, we pulled down the image, then we were able to run the container of that image. I would like to also mention that you can actually try to run the image even if you don't have it locally. Docker is smart enough to look in the local cache on your machine and see if that image exists. But if it doesn't, it will prompt itself to go download or pull down the image, essentially running the docker pull command in the background for us. Then when that is done, it goes forth to proceeding to running the container of that image. That all of that will make sense in a second, and I'll show you what I mean. So if I can clear my screen up for a sec there. If we do docker image ls, we can see that we have busybox, and that is the only image that we've got right now. Okay, so what we are going to do now, or want to achieve, is to run an image called nginx. And you can always check, don't forget, you can always come here and search for an image, any image whatsoever, and then you see things. Apparently, or luckily, nginx happen to have an official docker image. So but we will not be running docker pull ourselves this minute, so we'll see what docker does for us if we don't know what we want to do. If we don't have the image, of course we know what we want to do. We want to run nginx. So we'll run docker run nginx dash. Let's use all the commands we've learned earlier from the previous session and the flags. So another thing to note is that when you are issuing flags to extend a docker command, it comes before the image name. Okay, I'll take that again. Every time you are issuing commands with docker, and the command takes flags or arguments, right? Flag arguments. These flags come before the name of the image. I thought to emphasize on this because even myself sometimes this still is sometimes a gotcha. You just type it the other way around, but it's not too bad. You would easily figure it out in no time, but just I thought it was worth mentioning. Anyways, why don't we use all the flags we have learned earlier? So we do -- name, and we want to call this YouTube nginx. And then we have something called -it to run in an interactive mode. So for this case, running in interactive mode might not exactly be very useful, but we'll run it anyways. So you can see it couldn't find nginx locally, and then it went ahead to pull down nginx for us. And right after doing that, you see the status is downloaded new image for nginx with the tag latest, and it did what is expected of it by running the image locally. The thing we get here in interactive mode is that now I can do all of this, and then nginx is running, even though this makes I can't exactly interfere with it as it is, but then the image in the container is running. And we can also verify that, by the way, by saying docker ps, and you can see we have the container ID as you would expect, the image name, the command that is running. We'll see something about docker entry point here. We won't be diving too deep in that in this tutorial. When it was created, and you see, very important, the port, which is 80. Like I mentioned earlier, the default port for nginx is port 80. And as we can see, that the name we specify has been used here, which is YouTube nginx. That's cool. However, like I mentioned, nginx is a web server, and from what we can see here, it tells us it's running on port 80. So we don't have a problem with that, do we? So what we need to do is to look up our web browser, open up our web browser, and then we go to localhost port 80. Oops, nothing is showing. What could be wrong? Well, here's the thing. Remember earlier when we when I was introducing Docker, I said it's a containerization. So everything it's in a container, right? So that means your computer, your computer where you're doing this development is your host machine, right? And the container, of course, obviously is running in a container. Anyways, that being said, for you to communicate from the host to the container and vice versa, you'd have to do some, you know, have to jump through some oops, if I can call it that, because Docker wants to ensure that everything is doing is abstracted away, encapsulated. It's its own thing. If I can, if you get what I mean, it's its own thing, thereby not interfering with your system, your host machine, except you specify by asking it to. And even at that, it's as limited as what you allow it to do, or say take over for the lack of better word, on the host machine. Now in this case, what we need is to forward request from our host machine to the container in question. And how can we do this? Docker has yet another flag, as you can imagine. I'm going to stop this container from running now. Remember our command docker stop. We specify the container ID. Okay, maybe this time around we just use the container name, just to have some varieties there. And you see, this stopped immediately, and you can see it say exits. Sorry. Cool. But what we want to achieve is to see our default web browser on the browser. We have not been able to achieve that just yet. And how can we achieve that? Simply by by the way, guys, we are going to remove this IT flag because, like I said, and as we've seen earlier, we are not exactly able to interfere with the process of Nginx running really that well yet for now. So what we can do is to specify, remember the flag. The flag is -p. Remember, flags come before the name of the image, just right after the command issued. So with p, which is for ports that we want to specify, that is, we want to specify the host machine port and as against to the container port, that is where the host is going to forward from and to, right? So we are forwarding, we can specify any port as we please on our host machine. In fact, I'm going to probably do something drastic and say like 9,000, let's say port 901, and then to the container port, which is 80. We'll say map that to port 80. Important to note, when you are mapping things like this, for instance, the port, there'll be other things which will show. The first thing before the colon is the host, and the letter is the containers, whatever it is that you're specifying. In this case, we are specifying the port, right? So if we run this, why not? Okay, so we are going to run another image. We are going to run our Nginx image again, and we'll specify the container name also to be Nginx. So, and hopefully we should be able to access this on our host machine on port 901, and we should get the default Nginx page. Let's see how that works out. So we say localhost 901, and if we come here, voila, wow, we have a welcome page to Nginx. This is just a tip of the iceberg when it comes to Docker, and even though we've covered pretty much some day-to-day use cases of what you might and what you will be using Docker and how you will be using it mostly. This is a very basic of things, and trust me, this is pretty much on the basic level, things that you need to know to get started, and then get a feel for things, and then you move from there, right? Before we go on, there are a few other commands I would like to show you. The first one being exec. Exec will be able to poke into the container itself, like, okay, yeah, we understand now that container has spawned off images. What did the image even do in the first place, right? Okay, now a container is running my application. All right, what exactly in the world is container? What is it doing? How does it know what to do? Well, there is a command for which you can poke into the container and see things, that works. The command is called exec. So we say docker exec. Remember that flag it to be interactive. So we say docker exec -it. Actually, we need to know the container ID in which we are running, even though we can use the container name, to be honest. But yeah, I generally just pick saying docker ps. Now I know for sure that this is the container ID, and as you can see, guys, it's forwarding of port 901 to port 80 compared to what we saw earlier, which was just 80 on TCP, and the name is Nginx. So what we can do now is exec. What we want to do, in fact, is to exec into the container is docker exec, and then we specify that IT flag again, which of course stands for the same thing, interactive. So we say interactive, and then we specify the container ID or the container name. For some reason, I'm finding myself specifying the container name, which is okay. And then we specify how we want to access it. In this case, I want to use SH shell. So if you're ls here, you'll see this is everything that the image has prepared for us to be able to spin off container of it. So every container that is spun off Nginx would have the same thing in them, which is pretty much everything that Nginx is using to run. Anyways, so particularly what I'm interested in, or what I would like to show you, is how we can modify things in a container. For instance, this website, this default web page, let's change it. Let's change everything. We can do so if we know where the file that is showing us that web page is, and we do know, and we can always find these details in the documentation. Once again, I believe it's in. So if we go to, let's share yeah, it should be in user share Nginx, yeah, HTML. Oh, great. ls/user /share/nginx/html. As you can see, we can see the index.html, and if I cut this file, we'll see that we have exactly what we have on the web browser, which is welcome to Nginx and all those bang that were there. Yeah, welcome to Nginx. If you see this page, the Nginx web server is successfully installed and working. Further configuration required. And if we come here, yeah, that is exactly what we are saying. So what if we want to change it, right? What if we want to change everything? We want to welcome ourselves, and we don't want Nginx to welcome us, right? We could do something. In fact, let's just overwrite the entire file. So we can do. This is a basic. This is a just a very dirty way to just do it, but you can literally do anything to overwrite that file. Honestly speaking, trust me. But I'm just gonna say we want to welcome ourselves. Welcome YouTube family to Dockerland. cheesy. Anyways, and then we can just overwrite the entire file. And if we do this, this is just literally just overwrote that entire file. And if we cut this file again, you should see just that. Welcome YouTube land. And if we come to the web browser, we literally just did that right now. We overwrote the file. And that is exactly how we can manage our software project as well, right? So this will lead us to something called volume. But before we go into what volume is and how to use it, I'd like to show you something so you can see the importance of volume. If I stop this container from running, remember we literally just changed this whole thing. So what happens if I do this? Docker stop nginx. Right, we don't have any container running anymore. Okay, now let's spin off the same container. We can specify, by the way, we can specify --rm so that it removes the container and everything relating to that container when we stop the container, so it doesn't leave any cache or anything whatsoever. Which is part of the reason why we're seeing that the error earlier that was telling us that we had given the same name, which if I run now, yeah, I will get the same conflict. And I'll just keep this a 1 so that I don't have to deal with it. So if we go back to the browser, hopefully we should see this. I need to reload this, but shoot. That ain't good. We didn't, at least I didn't see that coming. I hope I don't know about you guys, but anyways. Now this brings us to the concept of what we call volume in Docker. And what volumes are essentially are data source, right? It allows us to map data source from our host or from remote host, as the case may be, to our container, our running container. So I'll show you how that works in a minute, and then we'll see the importance of it. So let me show you this. I will stop this process from running, and if I run this again, yeah, cool. So you can see that I'm not getting that issue of RM. Of the same name being used. So to use a volume, we need to specify another flag. It's called -v, v as in volume. And remember, when we are specifying things on a flag or to map between host and container, the host comes first, then the container thereafter. I am going to be mapping in, I believe I have a directory here that I use called, okay, yeah, here, to be honest, pretty much. You can map it anywhere you so please. So I'm just gonna put it on my root directory called tutorial, and then we'll do slash let's say yt nginx, right? And this is actually going to map to a real directory on my machine. And should this directory not be available, it would create its own. It will actually auto create it, and we want to map this to the container spot, which we already know to be in user/share/nginx/html. Okay, and so this is expecting to find this is actually already mapped. So if you put anything in the host that overwrites something in the container, sure believe that would be overwritten. Whatever that is, it will be overwritten. So we can see that in action by doing this. If I did this, you know what, let's just do pwd, right, my present working directory, and then I go from there. So this should solve it. Yes, it did solve that. Okay, and but this changes nothing, as you can see. If we came to this place now, in fact, looks like it added more to our problem. And the reason for that is because Nginx expects a default index.html file. And now that we've mapped that directory to the directory in the Nginx container, by default, it would overwrite whatever content is in the container, right? Because the volume is now the source for data persistence, right? So it's overwritten that, and the directory is empty. So Nginx cannot find the index.html to serve, hence why we're getting this 403. So what we can simply do is add an index.html in our volume path, and then we would be fine. And we can see that in action. Oh, we should be fine, hopefully. This log is starting to annoy me. What we can do before we go changing the index file, let me quickly show you something. When we don't want, these chatty long logs, what we can do is specify yet another flag. Yes, another flag called -d. This would run this process in the background, and we would not have to worry about these old logs. So we can do -d as in to run the process in the background. This is the container hash, and we can verify that if we run docker ps, you can see that, yeah, that's the few byte of the container ID. Anyways, so let's go back to the problem at hand. We need to add. So the solution to this problem is to pick this our mount part of our volume and provide a default index.html file in there, and everything should be fine. And we can see that by, I can just open this right in VS Code, and let me just create an index.html file here, and I believe we should get this, and let me put some h1 hello YouTube family. We can just duplicate this for the sake of, just to have something there. Anyways, so by doing this now, we have our volume, and the good thing about this, I believe, if we reload this, the volume just works, right? It's automatically, read into the container, and you can see we have hello YouTube. We literally just did that directly from our host machine based on the path that we mounted, right? So with this, we've gone through some interesting use cases of volume, and as well of Docker in general. We've spoken about how to, use Docker commands, listing images, running containers, execing into the containers, like poking into the container, seeing what the container is made of. We've spoken about specifying ports as a flag to the run command. We've spoken about volumes, and all of this was really nice. We are just using people's images, right? How about when we want to create our own custom image? And that's something I know you would like to do, and push that up to a remote registry like Docker Hub. So without further ado, I'll show you that in the next video. Stay tuned. Please do like this video, and please share with your friends, and remember to subscribe to my channel. Remember to turn on your notification bell, guys, so that when new video drops on this channel, you'll be the first to know. I'll see you on the next one.